Algebra 1, Lesson 7.6, Exponential Functions. Our objectives today is to evaluate and graph exponential functions. So, as we are looking at our functions, today as you fill in your notes, or on your green notes on that back page, the essential understanding is that some functions model an initial amount that is repeatedly multiplied by the same positive number. In the rules of these functions, if we are looking at them, the independent variable is the exponent. So an exponential function is a function of the form that you're going to put this down in your notes. Y equals a times b to the x, where a is not 0, b is going to be greater than 0, b cannot equal 1 because then it's not growing, it's linear, and x is any real number. So if you need to pause the video right now in class so that you can put these two examples, where you have this red line drawing a graph with the y-axis, y equals 2 to the x, y equals negative 2 to the x. These are both considered growth functions, even though this one is going down. Here we have a decay function, which we'll talk about later in this chapter, y equals 1/2 to the x, and y equals a negative 1/2 to the x. So this should be in your notes on your green page behind that exponential function. Pause it, start it up once everyone is copied. As you put in your notes, we're going to look at some examples. It says, suppose the x values in the table have a common difference. If all the y values have a common difference, the table represents a linear function. If all the y values have a common ratio, then the table represents exponential growth. So remember, linear is when you add or subtract, exponential is when you're going to be multiplying or dividing. So it says identify if it's linear or exponential. On your worksheet you'll get today, you'll also be asked to identify linear, exponential, and absolute value. In this first case, we look at our table. The x's are going up by 1s. The y's are being multiplied by -3. So it has a common ratio of 3. Thus, if we are looking at that first table, and we are looking here, and we're looking at it, if we want to write that, we're going to look at our equation. And does it represent exponential or linear? This one would represent exponential. This second equation, y equals 3 to the x, we already know that's in linear form. That would be linear. It's your turn now. We're going to pause the video so that you can take a look at these two rules and try and decide, should it be exponential or linear? And then you're going to, when the video is done being paused, we'll start it up again, the sub will start it, and we'll look at the answers that you chose. So it should be paused at this point. In the first one, as we look at that equation, our x's are going up by 1s, all y's are continuing to add 2 each time, so this would be linear. What would our equation be? Well, if we had a 0, we'd go back 2 more, we'd have -3, we'd have y equals 2x minus 3. In this next one, for each value you put in for x, because you're multiplying, this one is going to be exponential. And if you wanted to look at a table of values, we could do that. When x is 0, we're going to have 3 times 6 to the 0, which is simply going to be 3 times 1, or 3. If we put in 1, 3 times 6 to the 1 would be 3 times 6, or 18. And if we look at 2, we have 3 times 6 to the 2, which would equal 3 times 6 squared, or 3 times 36, to get our next solution, exponential. In this next one, you're going to be asked to evaluate an exponential function. Population, suppose that we have 30 flower beetles left, undistributed in a warehouse bin. The beetle population doubles each week. So here's the function that we are going to be looking at. F of x is equal to 30, our initial, times 2, because it's doubling, to the x power. Gives us the population after x weeks. How many beetles will there be in 56 days? Well, if we are looking at this, we're going to start with our function, 30 times 2 to the x. Why do we want to replace x with 8? Well, 56 days is actually equal to 8 weeks. So x is going to be 8. So we're going to have 30 times 2 to the 8th, which is 256, gives us a population of 7,680. After 56 days, that's how many beetles we would have. Now it's your turn to do the got it An initial population of 20 rabbits triples every half hour. The function is f of x equals 20 times 3 to the x, where the population after x half-year periods, how many rabbits will you have in 3 years? Now remember, it's tripling every half year. So in 3 years, we're actually going to have x equaling 6, because we would have 3 half-year periods. Try it now. Pause the video, and everyone put it in your calculator, write down your work, and then we'll start it up again. As you start it up, f of x is equal to 20 times 3, and our x is going to be 6. So 20 times, we're going to take 3 to the 6th on our calculator. You're going to be using your calculator, so 3 to the 6th is 729, and you're going to now find out what our new population of rabbits is going to be. In problem 3, they're going to ask you to graph. You're going to be doing some graphing also. I'm going to set you up with some tables. You're asked to graph 3 times 2 to the x. As we do these problems, you're going to go again like we did with our absolute value with -2, -1, 0, 1, and 2. As you look at filling those in, the key thing is that you show your work. It says, what's the domain and range of our function? Any value can be substituted for x and in a positive y value. So the domain is going to be all real numbers, and in this case, our range, you'll notice, is always going to be our positive number. So we make our table, and you're going to start it off, and you want to copy this from the book, 3 times 2 to the -2. Remember, that's going to be 3 divided by 2 to the second, so 3/4. So our first point, -2 3/4. Second one, -1. 3 times 2 to the -1 is 3 over 2 to the first, or 3.5, 1.5. Anything to the 0, remember, is 1. So 3 times 2 to the 0 is 3 times 1 and 3. The point will be at 0, 3. That's our y-intercept. Remember our initial value, y-intercept. Now we replace it with a 1 and get 6, and 2 and get 12. And you're going to plot your points. What I would like you to do right now in the got it part is you want to make a table of x and y values for both of these, and then pause the video so that you guys can actually do this on your paper. We're going to go with -2, -1, 0, 1, and 2. And again, I'm going to have this up, pause the video, and then you will be able to see these values filled in, and then you can kind of check your work. Key thing to keep in mind on the got it part, why does the graph of an exponential function of the form y equals a times b to the x? If b is non-zero, have a y-intercept of a. And the key thing I want you to think about is that why is this our y-intercept as you look at that, and we'll show that in just a minute. So at this point, you're going to pause the video, and we're going to do these functions, and then you'll see the answer. So you should start making your tables. I'm going to start the first one for you to show you the work you should have, then you're going to do the second one and pause it. As you're looking at this first one, we are starting out with 0.5 times 3, if we're going to take it to the -2 power, that actually means 0.5, and on your calculator you're going to take that times 1/9. When you put that in your calculator, you actually get a very small decimal, 0.05. So our first ordered pair that we're going to graph is going to be -2.05. When you put in -1, we have 0.5 times 3 to the -1, which is the same as 1 over 3 to the first. So 0.5 divided by 3 gives us 0.1 with a 6 repeating. So our second ordered pair that you're going to plot on your graph would be -1 and 0.16 repeating. When we plug in 0, we get 0.5 times 3 to the 0, which is the same as 0.5 times 1, which gives us 0.5. Our 0, our y-intercept is 0.5. When we plug in 1, 0.5 times 3 to the first power, which is going to be half of 3, which is 1.5. The next one is going to be 0.5 times 3 to the second, or half of 9, which gives us 4.5. So we should have our 5 ordered pairs that we are looking at, and we are going to plot those. And as you plot those, you can just do a rough sketch on your paper graph. We are looking at your y-axis and your x-axis. we need to have, remember, our domain is all real numbers, but our range is just, in this case, going to be positive since our y-intercept is positive. So if I am plotting my points, the first one, -2 and 0.05, that is so close to the y-axis. Then I have -1 and -1.6. Again, here we have a half as our y-intercept, 1.5, and then we're at 4.5. So if I'm looking at the graph of mine, it should curve upward, but this never touches the y-axis and just gets closer and closer to that x-axis, but never touches it. You're going to try this next one. You should find your values. Hopefully, pause it and try that. Now that you're back, you should find your y values to be the same here, only negative. So when you go to make your graph, this time, we're going to have our y-axis and our x-axis. And this time, the only thing that's different about this graph is that you're going to notice that instead of it going up, it's going to go down because it was a negative y. Here's another one with a story problem. Take a look in your book, and what I want you to see is that when we compute this using our table, that a lot of times we're only looking at our positive values. So a software company allows you to zoom to an area of more detail, 100 times 0.25 to the x, and here's what your graph looks like. And what you're asked to do is how do you graph this, and you're always going to start with making your same table. And what you're going to notice now is that you're going to be looking at this one. This one is quadrupling. So we're going to look at that percent change, and we'll look at that got it probably tomorrow as well. Right now in your homework, what you're going to be asked to do on the worksheet, you're going to have one worksheet tonight and probably a second one tomorrow. What you want to do is you want to graph your values. And as you look at your table, we are looking at this table, and it just asks you what type of function it is. So make sure, though, notice that your y values here, that your y values go from 1 to 81. So when you graph it, your y values have to go up to 81. So make sure you have the appropriate scale. As you take a look at your x values are going with 1. My suggestion would be go 0, skip 1, go 1, 2, skip and go 3, and skip and have 4. And again, as you look at 2, again, look at your scales. Same thing here. I would make sure that I have 0, 1, 2, 3. And again, what they're asking you, what type of function, you're going to say if it's linear, exponential, or absolute. And if you can, try to write an equation. If you're not too sure about the exponential equation, I would be okay, but the other two you should be able to do. You're going to do the same in 3. And in problem 4 and 5 on your worksheet, graph the points. The only thing is sometimes really look at that y-scale to make sure it will all fit. And then the next worksheet that you're going to be getting, and you should have and tomorrow we're taking your quiz, so you can leave some of this for after your quiz. The second worksheet that you're going to get is just going to ask you to tell whether these points work. So read the problem and show your work. And what I'm looking for your work is that you show me that this works. My example is this. Y is 3. Does that equal 3 to the first? You then want to show me that yes, 3 equals 3, and you're going to say yes, this is a point on this equation. You're going to do the same through 9. If you want to try starting these, putting down what your values will be, and then we'll be looking at this tomorrow in class right before your quiz.